Hello, welcome to our subject Techno Apps. Again, I'm your teacher, Shalome W. Pareja. For week 4, let's talk about temperature sensors and push buttons. Temperature sensors measures temperature. Temperature is the degree of hotness or coldness in a substance. There are different classifications of temperature sensors. These sensors that can change in dimensions or function of a temperature. One very popular example is your mercury thermometer. Another type of sensor is your thermistor, where the resistance changes when the temperature changes. On the other hand, thermocouples operate on the voltage difference of two conducting metals. They are the most popular and relatively inexpensive. The temperature sensors that we'll be using in our activity or in our discussion is TMP36 thermistor semiconductor sensor type. The TMP336 is a low voltage, analog, precision centigrade temperature sensor. Its voltage output is directly proportional to Celsius temperature. Its range is from negative 40 degrees Celsius up to positive 125 degrees Celsius. In figure 1, it is an LMT5 sensor which is very similar to TMP336. One connects to the 5 voltage supply and 2 is the output voltage that is dependent on the ambient temperature. 3 is connected to the ground. Temperature sensors application. All applications that need temperature measurement utilize this sensor. Almost all home appliances and industry equipment require temperature measurement. Automatic washing machine requires temperature sensors to verify water temperature. Automotive engines need to monitor its temperature to prevent overheating and to control combustion. Inverter air conditioners regularly measure ambient temperature and compare it to the set temperature. Power plants use multiple temperature sensors to monitor and check if the equipment is still safe operating conditions. In the past week, we often use the platform to manipulate things. Now, we will be using switch as inputs, conditional statements to make decision and random function. Conditional statements are essential to C programming. It allows you to execute a segment based on a decision. Ang conditional statement is in Arduino IDE are pretty similar to the conditional statement in C language. Now, we have here our push button. Push buttons are often called tactile switch, are momentary switches that are capable of turning any electronic device to either on or off state. When a momentary switch is not actuated, it is not called normal state. A normal state can be an open circuit or short circuit. A push button acts as an open circuit unless it is actuated, is called normally open or NO. In this kind of push button, once you push the switch, the circuit will turn on. But when you let the switch, it reverts back to off state. This type of momentary switches are common and is used in different devices and machines. Contrary, a less common type is called normally closed or NC. It has the opposite function of NO or normally open. Once you push the switch, the circuit will turn off. But when you let the switch, it reverts back to on states. So here is the comparison of different operators. We have here the syntax, descriptions, and example. Comparison operator are operators or symbols that compare two values. Often, these symbols are in conditional statements and loop. It tests if a certain condition has been reached, execution will proceed. Now, here are the Boolean operators. Boolean operators are operators that is used to manipulate true or false value, often inside the conditional statement. So here we have the syntax, description, and operators. Conditional statements are essential to C programming. It allows you to execute segment based on a decision. Conditional statements in Arduino IDE is pretty similar to the conditional statement in C language. If, else if, and else statement. If statement allows you to perform some task depending on whether a given condition is true or false. In the example, a LED will turn on once the condition is true. Next, else statement. It is used when a condition in if statement is false. In this example, if your temperature sensor reading is less than or equal to 24 Celsius, a green connected to digital pin 7 will turn on. If the reading is greater than 24 Celsius, a red LED connected to digital pin 8 will turn on. Else if. It blocks or allows multiple conditions or tests to be grouped together in a single loop. You can use unlimited number of else if branch in a single loop. So if the temperature sensor reading is less than or equal to 0 degrees Celsius, a blue LED connected to digital pin 7 will turn on. If the reading is greater than 0 but less than 24 degrees Celsius, a green LED connected to pin 8 will turn on. If the reading is greater than 24 degrees Celsius, a red LED connected to pin 9 will turn on. So using random numbers with Arduino. Generating random number is essential in every computing devices. It helps them to do tasks in random manner. Applications such as shuffling the audio files in your cellular phone or players to slot machine use random number generation. Generating random numbers in Arduino is quite a task. The closest you get in an Arduino is mimicking randomness using pseudo-random numbers. Pseudo-randoms are actually generated using an algorithm that produces number that appears to be random, but actually it follows a sequence. The random function generates pseudo-random numbers, but remember, when using the random function with Arduino, it just generates the exact same list of pseudo-random numbers every time it runs. An easy way to overcome this is by using random seed function. This function initializes a random number generator with random input such as analog red, an unconnected pin to alter the random list generated by the random function. Now, let's answer our objective test and performance test. And if you have any more questions or clarifications and suggestions, do not hesitate to email me at my email address, my contact number, or send me an SMS, my Facebook account, my MS Teams account.